Okay, so today in 5.4 we are going to integrate the exponential function. So we need to know the integral rules. Again, 1 is specific, 2 is general. Got it? Okay, so we have the integral of e to the x. Dx is e to the x plus c. Well, if the derivative of e to the x is e to the x, I guess the integral would probably be e to the x, right? The general rule is the integral of e to the u du is e to the u plus c. So I could write that. No, that is not equal. We could also write that as the integral of e to the u. No, it's all written good. That du could be d prime or u prime. Yes.
Yeah.
That's it. Sorry, there's no other way to write that.
Okay.
So other than eu, I guess there is that. I guess it could be the integral of e to the u prime, but it's just still the same thing, right?
Yeah, it is.
So sometimes I think these seem too easy. Like I'm going, there has to be more involved. But I think you found when you were doing the derivative yesterday, you felt like, okay, what else do I need to do? And there's nothing else you need to do. So we have the integral of e to the 3x plus 1. So u is 3x plus 1. And u prime is 3 dx. So what's missing?
Nothing.
Yes? And they're missing a 3 right here.
Okay.
So what do we have to add? 1/3. And so we have 1/3 the integral of e to the u du. So we just have 1/3 e to the 3x plus 1. How about 1/3 instead of...
I wonder where you got that from.
I said 3. My brain is lacking oxygen. Happened yesterday too. I could say the right thing or write the right thing, but I could not do both.
You don't have that. Who's your student of the week?
It's Samantha. I have a picture finally. It was Samantha last week, but she wouldn't let me take a picture. It's this week, and I haven't printed the picture, so I'm just on a roll.
You were like, I have a picture, but then I was like, am I missing a picture? Because I don't see a picture.
No, I got a picture of her in the lunch line. She's really going to love it. But,
She can't fix it.
okay, so the integral of 5x e to the negative x squared. So what's u? Negative x squared. So u prime is negative 2x dx. So what's going on this one?
Oh, we got a 5x, so we're missing negatives. 2 and 2 over 5.
It's negative.
Yeah, I said that like a minute ago. I just had
Actually, no, 5 over 2.
5 over 2.
Because we have to reduce out the 2's and add in a 5.
Yeah, you're right.
So I have the negative 5 halves, the integral of e to the u. You want to take Lily's too?
Yeah.
Yeah, we had that discussion. I told them to Snapchat you, and none of them got that your phones were here. They just said they didn't have you on Snapchat. See you later.
Yeah.
Okay, so I have negative 5 halves e to the negative x squared. You guys did not catch the missing plus c.
Why would I?
Did you write it?
Yeah.
Good. Did you two write it?
Oh,
Yeah.
I don't believe that. Thank you for being honest, Kale.
welcome.
That was on there. See?
Okay.
And we're done?
Well, I got more examples, but
Because, I don't know.
they're just different, variations that could pop up.
Like, should we just start working and then you just help us?
I don't care.
We do this slide of examples, maybe.
I have the integral of e to the 1 over x divided by x squared. So how should I go about picking u? Because last one it said use the bottom, right? Use the denominator.
Yeah, but I say we just want to use.
But on this one, I probably want to use the exponent.
So the 1 over.
Oops.
So
Mm-hmm.
when we're doing, you switched it.
I know, I switched it twice.
So okay, stupid question. So like in this, like when we're doing these,
Mhm.
you want us to do the one on the e, not the x, or does it matter?
Well, on these, we're focusing on the exponential function. So you probably want to use the exponent.
But they both
but
have
in-
exponents.
Yes, but e is a function. We're focusing on the exponential function. X squared is not an exponential function. An exponential function has a variable in the exponent.
So I pick the e,
You pick the exponential function.
which is e.
In this case, yes. But they're not, no, exponent, like 3 to the x plus 4 is an exponential function.
Why? Because it has more than one thing up there.
Because the
Because the
exponent
exponent
is the variable's in the exponent. E is a number. Remember, E is 2.718281828
Missed that lesson.
twice, 2 years in a row. Okay, 3 years in a row. E is a number, so it's the same as a 3. So, yeah.
So can I just always pick the one that's on the e?
They're not all going to be E. You always pick.
And it's a function. If
Okay, you know what? This is the thing. When you're picking these, pick the hardest one to deal with.
the one that looks hard.
The one that has more pieces. Because you're going smaller, so more pieces are easier to go smaller, right?
Okay. Well, I can remember that.
Okay.
Okay.
So which one do you pick then?
I'm not hard.
So you guys try to finish that one up.
I think they're all.
So do I have everything I need up here? Except for the negative. So I have negative the integral. And I have a real hard time of like writing all of this because I'm like, I want to go straight to the answer. Okay, so it's just negative e to the 1 over x plus c.
Yeah.
Okay. This step for me, you will tend not to even see on these problems because unless there's a bunch of steps in there, I don't do it. Okay, so now, what is u?
Cosine.
Cosine of x.
Start with this one.
Okay, so what's u prime?
Negative sine of x.
Okay.
Oh, don't take my shine. That's as far as I got this. You can take over now.
Okay, so do I have everything I need? And not the negative. So all I have to do is add a negative. So I have negative the integral of e to the u du. So I now have negative e to the cosine of x.
You just ignore the first sine of x. We just
No, because I didn't ignore it. It was u prime. Because the rule is e to the u prime.
Hey, you
Oh,
forgot
yeah.
your DX there, Mrs. Blake.
Oh,
You could do that.
what?
I just said how could you?
Oh, I thought you were asking a question. Okay, now I have implicit. Is it going to change what I do?
Well, a little bit.
A little bit, not much.
Yeah, you're doing implicit.
What's implicit again?
The 0 to 1.
Oh yeah.
The other ones were indefinite. Now I'm actually finding the area between 0 and 1 under the curve.
The other ones are just like x and
Yep.
these are like
So that's why we had, yeah.
specific.
Okay, so u, negative x, u prime is negative dx. So can I just jump to the answer?
Yeah.
So it's negative e to the negative x from 0 to 1. So then I get negative e to the negative 1 minus plus. Why is it plus? Because minus and negative is plus. And negative x, well, x is 0, so we can't have a negative 0. Anything to the 0 is 1. And so I got negative 1 over e plus 1. And then evidently I was feeling like I needed to get common denominators earlier on my work. So I have 1, nope, I have e minus 1 over e. Just because I think in the book, if you look it up, they'll have like an approximate amount. So how would you get an approximate amount?
You'll approximate it in your calculator.
Yep, in your calculator. What about this one? Now this one's a little bit different.
Use 1 plus e to the x.
You use 1 plus e to the x. Why, Kale?
Because, well, I can just tell that that's what we already did.
Right, we have the derivative on the top, right?
Yeah.
And then that means we can use logarithmic rules. So e, nope, u equals 1 plus e to the x. And u prime is e to the x dx. So that means I got everything covered, right? And since the numerator is the derivative of the denominator, that means I can use natural log.
Yeah.
So I have the natural log of the absolute value
And
of u, which is
to
1 plus e to the x.
plus c.
Nope. 0 to 1.
Yeah, okay.
So I have the natural log of 1 plus e to the first minus the natural log of 1 plus e to the 0. Okay, e to the first is e to the first, right? And so I have natural log of... And actually, do I need the absolute value anymore? No, because it's going to be positive, right? Okay. And then e to the 0 is 1. So 1 plus 1 is 2. So the natural log of 2. And all I got is one more. And it's a trig one just for you, Cal. Am I good?
Yeah.
Okay. So, I have the integral from negative 1 to 0 of e to the x cosine of e to the x. So u is
E to the x.
e to the x. Which e to the x? The one in cosine or the one out of cosine?
1 into.
The one in cosine.
How do you know which one you picked?
Well, you need the one in the function because the other one, we want it to be the derivative, right? And what is the derivative of e to the u? Or e to the x? E to the x. Now, I am going to tell you a lot of times in my head, I'm going, okay, if I pick this as u, then my derivative is going to be this. I'm like doing the derivative before I start writing it down and trying things out. Okay, so now I have the integral, and I am going to write this one because it is a trig one, from negative 1 to 0 of cosine of u du. So what's the integral of cosine?
Negative sign.
So it's negative sine of u, which is
E to the x.
e to the x.
Do we want the integral or derivative of cosine?
No, we want to integrate it.
Just want it just be sine.
Yeah, okay.
Yes. Yes. Because we were finding, yep. Negative would be for the cosine. Okay, from negative 1 to 0. Thank you, Autumn. So I have the sine of e to the 0 minus sine of e to the first. Well, e to the 0 is 1. So I need the sine of 1 minus the sine of e. I put 1 over e, and I have no clue why. Oh, it's -1, not 1, and that's why. I was just looking at my answer. Because I have it there, I just didn't bring it. So negative would be 1 over e, right? If I brought my stuff down correctly. And that's it. And then you approximation with your calculator. Anybody tempted to say 90 degrees on sine of 1? No one? I had to stop myself.
9 degrees, I was just gonna say 0.
But it's not 0. I was in my head, I was like, where's the sine 1 at? I'm like, 90 degrees. I'm like, not what I'm asking. Okay, that's it.